A vendor review can pass, and a valid certificate can still move money, ship code, or change identity on the same day. The folder looks finished. The certificate is not forced the way a thief forces a lock. The certificate is the key the organization already issued, and the rail treats that key as the institution speaking. The review that stamped the vendor last year does not watch what that key does today. The breach used a valid certificate because the attack surface was not the vendor list. The attack surface was the trust already handed out. The grants already in other people's hands are certificates, tokens, API keys, signing keys, and delegated authority. The inventory that matters is which objects you issued, what those objects can already do, and how fast the grant can be taken back. A supply chain attack surface is the set of paths an attacker can use because you already trust someone else to act for you. You do not own those paths the way you own a laptop on your desk. You inherit them when you accept a certificate, a token, a build, or a support role. Inherited means the door was opened by a decision you made, not by a hole you forgot to patch. The inventory of vendors can be complete and the surface can still be open, because the inventory counts companies and the surface counts grants. Ownership and inheritance are different questions. Ownership asks which legal entity holds the asset. Inheritance asks which outside actor can already move money, change code, or assert identity in your name. A company can own the customer account and still inherit the payment pipe, the identity broker, and the update channel. The written contract can name the vendor. The attack surface is the privilege that vendor can already exercise. Legal title does not travel with a debit. The customer still calls the institution whose name is on the account, not the technology provider that held the certificate. The old perimeter assumption treated the company as a castle with a wall. Inside the wall sat systems you operated. Outside the wall sat vendors you audited once a year. That map is finished. Payroll runs in a cloud application. Identity is asserted by a broker you do not staff. Payments leave through a licensed pipe you do not operate. A wall that stops at the badge reader cannot see a certificate that already speaks for the bank. The perimeter was a staffing model as much as a network model. It assumed the people who could move money sat on your directory. That assumption died the first time a licensed provider was allowed to speak in your name. Third-party risk management is the discipline that finds and constrains the risk that arrives through vendors, partners, and service providers. TPRM does not erase that risk. A company that uses other companies will import some of their failures. The work is to keep the imported failure inside the board's appetite, which means naming the grants, not only naming the firms. TPRM only constrains what it can name, and the things that must be named are the trust objects already in other people's hands. A trust object is a credential, a certificate, a token, a key, or a role that lets an outside system act as if it were you. Attackers do not need to break a control if they can operate inside a trust object that the control already accepts. Breaking a control leaves a scar. Using a grant leaves a session. The interesting question is not whether the vendor is on a list. The interesting question is which objects you already issued, what those objects are allowed to do, and how fast the grant can be taken back. Credentials and certificates are the first family. A password, a hardware token, or an institutional certificate from PKI, which is public key infrastructure, can authorize a person or a machine. An institutional certificate is a signed identity the rail treats as the institution itself. If the private key that matches that certificate is taken, the next message is still valid under the protocol. The control sees a permitted speaker. The business sees money leave. Validity is a protocol fact, not a comfort fact. A certificate can be unexpired, unrevoked, and correctly chained, and still be in the wrong hands. API tokens and OAuth tokens are the second family. An application programming interface is a machine-to-machine doorway. A token is the machine password that doorway accepts. OAuth is an open authorization protocol that issues a token instead of sharing the account password. A token that can post a payment, read a mailbox, or create a user is already a path. Rotating a password does not close that path if the token remains valid. Scope is the real control. A token that can only read a test queue is a small grant. A token that can post into a production rail is delegated authority with a shorter name. Federated identity and CI/CD are the third family. Federated identity is a login that another company asserts for you, so a help desk or a partner can open a session without holding your password file. CI/CD is the continuous integration and continuous delivery pipeline that builds and ships code. A support role that can reset a lockout is a trust object. A pipeline that can push a signed artifact is a trust object. Both look like work. Both can move identity or code without tripping a break-in alarm. The alarm was trained on strangers. These paths are staffed by friends of the architecture, which is why they need the same review as an internal admin. Signing keys are the fourth family. A signing key marks an update, a package, or a payment message as genuine. Customers install what the key endorses. Banks settle what the key endorses. The SolarWinds update path showed the software version of that fact in public. A trusted signature became the distribution channel. A payment rail shows the money version of the same fact. A trusted signature becomes the settlement channel. Protecting the key is not a ceremony you run once. Protecting the key is the ongoing question of who can use it, from where, and whether anyone is watching the endorsements it produces. Delegated authority is the name for the whole set. Delegated authority means you asked another party to act in your name, and the system treats that act as yours. A licensed payment provider that can issue an order into a national rail holds delegated authority. A managed service provider that can open an admin session holds delegated authority. You can delegate the act. You cannot delegate the impact. The organization still owns the impact because the account that moved, the code that shipped, and the identity that changed were yours. Attackers study those objects because operating inside the rules is cheaper than breaking the rules. A broken control leaves a scar a detector can name. A valid certificate, a signed update, an authorized support role, or a protocol-correct payment leaves a session that looks like Tuesday. The detector that only watches for deny events will bless the allow. That is why a past review and a successful fraud can share a calendar day. The review asked whether the speaker was enrolled. The fraud used the enrollment. Those objects only become a program when we can sort the paths they open, and the sort is 5 attack lenses, not 5 procurement categories. A procurement category asks what you bought: software, hosting, payroll, or a payment processor. An attack lens asks how an adversary can use the trust you already issued. The category comforts a purchase order. The lens names a path. One vendor can light more than one lens at the same time, which is why a single row on a spreadsheet is not a map. Categories are useful for buying. They become a blindfold when they are reused as the only risk label. The first lens is software and code. The path is a library, a package, a build server, or a signed update that your systems will accept because the source looks trusted. The SolarWinds Sunburst campaign is the public pattern. Malware entered the vendor build, and customers installed the result as a normal update. Seesaw published fact sheets on that campaign because a trusted installer is a delivery route. The review that only asks whether the publisher is solvent cannot see a poisoned artifact. Solvency answers whether the firm can pay its bills. The lens asks whether your build will accept what that firm signs. The second lens is identity and access. The path is a support role, a federated login, an admin token, or an institutional certificate that can already open a session. Public reporting on the Okta support path in 2022 showed a legitimate help desk window used as an entry. Privilege that a vendor holds must sit inside identity and access management, which is the system that grants, reviews, and revokes keys. If the key sits only in a folder for the written contract, it is not managed. A folder can prove that someone once approved the vendor. Identity and access management can end the session today. The third lens is cloud and shared infrastructure. The path is a region, a hypervisor, a control plane, or a managed platform that many customers already share. A defect or a stolen admin on that shared layer reaches more than one tenant. The CrowdStrike sensor update in 2024 showed the operational version of a shared layer. One flawed update halted a huge number of Windows machines with no attacker required. Shared infrastructure multiplies both accidents and intrusions because the blast is already wired to many customers. You do not need a new exploit for each tenant. You need one grant on the layer they already share. The fourth lens is data flow. The path is the actual movement of records, messages, backups, logs, or payment orders, not the logo on the invoice. Data can leave through a warehouse you never reviewed, a log shipper you forgot, or a payment message a licensed provider is allowed to send. The question is not where the vendor sits on an org chart. The question is which bytes can already leave, and which rail will treat those bytes as genuine. A data flow map is a list of movements. A vendor list is a list of names. Only one of those maps can tell you how money leaves the building. The fifth lens is transitive dependency. The chain is not a line. The chain is a graph. A fourth party is a vendor's vendor, a subcontractor, an open source library, a cloud region, or a licensed technology provider that several of your banks already share. You may never have reviewed that node. The node can still move your money or your code. Transitive means the trust hops, and the hop does not ask your permission a second time. If 3 of your critical vendors sit on one hidden platform, you do not have 3 independent bets. You have one bet with 3 invoices. Those 5 lenses sit on one table because a single provider can light more than one row. Software and code, identity and access, cloud and shared infrastructure, data flow. Transitive dependency. A payment technology provider can hold an institutional certificate, send payment messages, sit on a shared pipe, and serve many client institutions at once. That is 4 lenses before anyone opens a procurement category. A payroll SaaS tool can hold employee files, join identity, and sit on a shared cloud. A build vendor can sign code and reach production. A licensed payment provider can hold certificates, issue orders, and concentrate many institutions on one pipe. Prioritization that counts vendors will underrank that provider. Prioritization that counts lighted lenses will not. The lenses name the path. Trust abuse is what the path looks like when nothing is broken. Trust abuse is the use of a valid grant to do harm. The certificate is valid. The update is signed. The support role is authorized. The payment order is protocol correct. Nothing looks broken because the system is doing the job it was built to do for a speaker it already accepts. The failure is not a missing firewall rule. The failure is a grant that was larger, longer, or less watched than the work required. Abuse is the wrong word if it suggests a smashed lock. The lock opened because it was told to open. A valid certificate and a signed update are the cleanest examples. PKI exists so a relying party can accept a speaker without calling that speaker on the phone. Code signing exists so a customer can install an update without rebuilding it from source. Those designs are correct. They become an attack path when the private key, the build, or the enrollment process is taken, because every downstream control was trained to say yes. An authorized support role is the same pattern in human form. A help desk must reset a lockout. A vendor engineer must join a production bridge. Those roles are not defects. They are work. The session is permitted. The harm arrives when the role is broader than the ticket, when the laptop is thinner than the privilege, or when the grant outlasts the project. Minimum privilege is the name for keeping the grant as small as the task. A legitimate path that is not minimum is still a path. A protocol-correct payment is the money form of the same fact. A national rail is built to settle fast when a licensed speaker sends a well-formed order. The rail is not built to second-guess a certificate it already trusts. If the order is shaped correctly and the certificate is the institution's certificate, settlement proceeds. The detector that only watches for malformed messages will miss the one that is perfect. Binary allow or deny is the wrong instrument for that class of event. Allow or deny asks whether the speaker is on the list. Watching authorized behavior asks whether this speaker at this hour for this amount toward this destination still matches the work you thought you bought. The first question is enrollment. The second question is use. Trust abuse hides in use. A program that only enrolls vendors will keep blessing the session. Enrollment is a door list. Use is a film of what walked through. TPRM that files the door list and never watches the film will keep passing reviews on the day the money moves. A questionnaire can be current. A SOC 2 report can be on file. SOC 2 is a system and organization controls report in which an independent auditor tests a selected set of controls over a period. Those artifacts can all be true on the day a valid certificate moves money. The artifacts answer whether a process existed. They do not answer whether anyone was watching what the grant did after it was issued. The mechanism is easier to hold when it has a public rail, and Brazil's Pix system is that rail. Pix is Brazil's instant payment system. A person or a company can move reais in seconds. Settlement runs through SPI, the instant payment system operated inside SPB, which is the Brazilian payment system overseen by the Central Bank of Brazil. Real-time settlement is the feature customers want. Real-time settlement is also why a bad order is hard to reverse. Once the rail has treated the order as genuine, the money has already changed hands. Speed is not the vulnerability. Speed is the design. The vulnerability is a grant that can use that design without a second human pause. Licensed institutions do not all speak to that rail with software they wrote themselves. Many connect through a PSTI, a payment service technology provider authorized by the Central Bank of Brazil. That provider holds institutional certificates and API channels so it can send orders on behalf of client institutions. The certificate is delegated authority in a file. The rail does not see a vendor logo. The rail sees a speaker it was told to trust. Authorization by the central bank is a license to connect. It is not a promise that the private key will stay in the right hands. The license answers fitness to operate. The incident answers what the grant did after sunset. On June 30th, 2025, C&M Software, a central bank authorized payment service technology provider, was compromised. Public reporting described attackers using valid institutional certificates and the matching private keys to issue protocol-correct PIX orders into SPI and SPB. The orders were not malformed. The speaker was a speaker the rail already accepted. The mechanism is delegated trust, not a smashed perimeter. Client institutions had already handed the provider the right to speak. Attackers who held those certificates could debit reserve accounts at more than one client institution, because the pipe was shared. Public estimates for the movement sit around 800 million reais, with some recovery later reported. Treat that figure as a public estimate, not as a courtroom total. If later reporting moves the total, keep the mechanism. The teaching point does not depend on the last digit. The teaching point is that a valid grant moved money at rail speed for more than one client at once. Settlement was real-time, which is why the window to stop an order was measured in the design of the rail, not in the design of an after-hours ticket. A batch system gives an operations team a pause. An instant rail does not. Hard to reverse is not a slogan. Hard to reverse is what real-time settlement means when the certificate was valid. The organization still owns the impact, because the reserve account that moved was the institution's reserve account. The Central Bank of Brazil suspended C&M Software's SPB connection. That decision cut the abused path. It also halted honest PIX traffic for every client institution on that same pipe. Revocation is not free. The control that stops the attacker can stop the honest payment the grocer is waiting on. Concentration turns a security decision into an availability decision for every customer who shared the provider. On August 29, 2025, a second provider incident was reported around Sinqia, later discussed with Evertech. Public reporting described unauthorized PIX activity that used legitimate information technology provider credentials. The public figure sits around 710 million reais attempted, with some of that blocked or recovered. If later reporting moves the total, keep the mechanism and drop the precision. Hundreds of millions of reais on a valid credential is the class of event. The class does not need a fictional integrator to be taught. The two incidents do not need to share a brand to share a structure. Valid credentials, one-to-many pipe, protocol-correct orders, real-time settlement, revocation that also takes down honest traffic. The vendor list at each client institution could have been tidy. The attack surface was the certificate, the API channel, and the delegated right to speak. Attackers operated inside the rules. One shared provider multiplied the blast. Each institution still owned the impact on its own reserve account. A licensed pipe that many institutions share is fourth-party risk with a national blast radius, and that is why the graph has to replace the list. The PIX pipe was a fourth party that most client institutions never named on the purchase order. A licensed payment service technology provider sat one hop behind the invoice, held the institutional certificate, and could already speak. If that hidden node fails, you may learn about it only after the debit. The money that moved was still yours. Suppliers of suppliers stay invisible when intake only records the company on the invoice. The invoice names the integrator. The integrator already depends on a cloud, a certificate authority, a messaging bus, and sometimes another licensed pipe. Each hop adds a trust object you did not enroll. A program that cannot name the hop cannot revoke the hop. And a program that cannot revoke the hop does not manage the surface. An aggregation point is a node many of your vendors, or many of your peers, already share. The payment service technology provider in the PIX cases is an aggregation point. A single identity broker used by a whole sector is an aggregation point. A single cloud control plane under a popular SaaS tool is an aggregation point. Aggregation is efficient for operations. Aggregation is a multiplier for an attacker because one stolen grant reaches a set, not a singleton. Efficiency and blast radius are the same drawing. The drawing looks like savings in a budget meeting. The drawing looks like a national incident when the grant is abused. One-to-many blast is what aggregation produces on a bad week. One provider, many client institutions, many reserve accounts, many honest payments that stop when the pipe is cut. The CrowdStrike outage showed the operational form of one-to-many. The PIX incidents showed the payment form. Different industries, same geometry. The geometry is why a medium-sized technology vendor can outrank a large but isolated supplier on a serious tiering board. Revocation that also takes down honest traffic is the bill for concentration. Boards like the sentence, "We can cut them off." Cutting them off is a real control. It is also an outage for every customer still on that certificate, that token, or that pipe. The question to ask before the incident is not whether revocation exists on paper. The question is how fast you can revoke, what honest work dies in the same minute, and whether a second path exists that was tested. A revoke plan that has never been rehearsed is a hope. A second path that has never carried a payment is a drawing. The chain is a graph, which is why a vendor list keeps lying. A list is one column of names. A graph is nodes and edges. Who can speak? On which rail? With which certificate? Into which account? On behalf of whom? Edges are the attack surface. Nodes are only the places those edges land. TPRM that inventories names and skips edges will keep passing reviews while a valid certificate still moves money. A taxonomy earns its keep only when it changes a decision, and the decisions are priority, depth, and evidence. The taxonomy is the 5 lenses used as a shared language, not as another filing cabinet. Which lenses does this vendor light? How wide is the blast if the grant is abused? How fast can we revoke? And what honest work dies when we do? Those 3 questions turn a threat picture into a TPRM decision. Prioritization changes first. Count lighted lenses, not the size of the purchase order. A cafeteria vendor and a payment service technology provider are not the same criticality. The cafeteria vendor rarely holds an institutional certificate. The payment provider can light identity, data flow, shared infrastructure, and transitive dependency in one relationship. A high-lens vendor goes to the top of the board, even when the invoice looks modest. A low-lens vendor can take the light path without pretending the risks are equal. Spend the scarce review hours where a stolen grant can move money, code, or identity for many customers at once. Depth of assessment changes second. A vendor that lights one quiet lens can take a short questionnaire. A vendor that lights identity plus data flow plus a shared pipe needs architecture, enrollment records, and a revoke rehearsal, not a longer version of the same form. Depth means different questions, not more pages. Ask who holds the private key. Ask which client institutions share the pipe. Ask what happens to honest traffic if the central bank or your own security team cuts the connection. Evidence changes third. Recent and specific beats an 18-month attestation. Attestation is a vendor's self-report about a control. It is useful. It is not a watch on today's certificate. Ask for the current enrollment list, the last key ceremony, the last revoke test, and the names of fourth parties added since the last review. A SOC 2 letter that is a year and a half old cannot see a private key that was copied last Tuesday. Point in time is a photograph. Certificates, tokens, and pipes change after the photograph. Age is part of the evidence. A specific artifact from last month beats a polished letter from last year. Shared language is what lets procurement, security, legal, and the business argue about the same object. Which lenses? Blast radius. How fast can you revoke? Those 3 phrases fit in a steering meeting without a glossary war. Legal can put revoke speed and notice duties into the written contract. Security can put the certificate into identity and access management. The business can decide whether a second pipe is worth the bill. Without the language, each room keeps winning its own score and losing the path. The score of a cheap deal is not the score of a grant that can empty a reserve account. Those 3 decisions sit on one table. Prioritization counts lighted lenses, so a shared payment provider outranks an isolated supplier. Depth matches the lenses, so identity plus a pipe gets a rehearsal, not a thicker form. Evidence stays recent and specific, so an 18-month attestation cannot stand in for last Tuesday's key. The taxonomy is doing work when a deal is delayed, a grant is shrunk, or a second path is funded because those rows changed someone's mind. The organization still owns the impact. Regulators, customers, and correspondents do not split the blame between the brand and the licensed provider. The reserve account was yours. The customer who could not pay was yours. The headline will carry your name. Treat the certificate as an extension of your own identity store. A weakness you would not accept on an internal signing key should not be acceptable on a vendor certificate that can already speak for you. A review can pass while a valid certificate still moves money, code, or identity. The supply chain attack surface is inherited trust, not a wall you own. Trust objects are credentials, certificates, API tokens, OAuth tokens, federated identity, CICD, signing keys, and delegated authority. 5 attack lenses sort the paths: software and code, identity and access, cloud and shared infrastructure, data flow, and transitive dependency. Trust abuse looks authorized. The PIX cases showed delegated trust, real-time settlement, a one-to-many pipe, and revocation that also halted honest traffic. Fourth-party risk is the graph behind the invoice. The taxonomy changes priority, depth, and evidence, and it gives the rooms a shared language. Which lenses, blast radius, how fast can you revoke? A grant shrank, a revoke was rehearsed, and a second pipe was funded because lighted lenses outranked the invoice. Thank you.